So let's not talk about what we cannot do with pointers and what we should not do, but let's start by this time talking about what we can do with pointers. Okay, so we're going to revisit a very basic example again. This is my pointer named PTR. Okay, I'm pointer on int, and I just so happen to have an int variable here named data inside my main. So I'm going to initialize this pointer to null, and then I'm going to initialize to this pointer assign to this pointer the address of variable data. Okay, so I'm introducing a new operator here. Here the star operator is used to declare a pointer. Here the ampersand operator is address of operator. It's followed generally by a name of a variable, and it's going to take the address of this variable. So this expression here results into the address of data, which is assigned to PTR. Now we have a pointer PTR, which is pointing to the memory space used by the variable data. So the variable data is an int, PTR is a pointer on int, perfect. A pointer on int is meant to point on an int, okay? And now I can use the dereference operator to assign a new value to whatever memory space I'm pointing to with PTR, which is corresponding to the memory space occupied by the variable data. So this is not doing anything really exciting. Okay, I'm just going to compile it to make sure there are no syntax error, but running it at this point is not going to do much. It's just going to show you that I can modify data by assigning directly values to it, or I can modify it after assigning its address to PTR by using PTR. So let's go. Let's write a little bit of code that is going to illustrate what's inside of data before my star PTR is assigned 999. So here, and after. So I'm just going to do a cut and paste here. There we go. So again, compilation, run. Data is 42. Well, that's what we initialize it with. Then we assign to PTR the address of that variable. And then we manipulate this variable through the pointer by dereferencing PTR and overwriting what was at that address, that is 42, by 999. Okay, so it's working. Let's take a look again. Stack diagram to explain what's going on under the hood. Okay, this is my program execution stack here. Text segment, data PSS. And this is my main function activation record, which has a local variable named data, initialized to 42, a local variable named PTR, initialized to null. We execute assign the address of data to PTR, so let's assume that the data variable consists of the 4 bytes starting at address alpha. I'm assigning this address to PTR, so that means that from now on PTR points to this location in memory. I display the value of data, obviously is 42. I dereference PTR, so dereference PTR. Okay, I evaluate this expression. This is simply a variable, so it results in its content. The content is alpha. I'm dereferencing alpha, which means I go to memory address alpha. And because PTR is a pointer on int, I'm looking at the 4 bytes following this address alpha. Okay, 4 bytes are used to code an integer on this specific platform I'm using. And then I assign 999 to those 4 bytes, encoding them as an integer, still because PTR is a pointer on int. Okay, so that tells me how to manipulate the data at that address. So I overwrite here 42 by 999. Okay, and this is exactly what's happening here with pointers. So we have something that is more functional, obviously, than what we had before. Okay, we're not dereferencing a null pointer. This time we're dereferencing a pointer that holds a meaningful address. Generally, when we are at this stage of explaining pointers, students really wonder why we bother, because, well, I could modify the value inside of data simply by writing data is assigned 999. So this is a fancy way, to create a sort of alias on a variable, but the usefulness of it is not evident in this type of, very, academic example there. So what we're going to do next is we are going to progressively incorporate pointers in other aspects of the language, like see how they interact with functions, and we're going to pretty much reveal their main application. To give you a little spoiler, we are going to look at two main applications of pointers, which are really core to understanding the C language. One of them is how pointers allow us to pass parameter by reference to function. And the second is going to be how pointers allow us to allocate dynamically, that is at runtime, some memory, and then refer to it. And once again, sorry about that, I'm going to remove this.